use electricity for many purposes in our daily lives. If we were to list these, the list would be extremely long. The water pump in your home, the metro, the trains, the factories, lights in our houses, streets, markets, all of these use electricity. The electricity for general purpose comes from the power station. But sometimes after sunset, we even use a torch. How does the torch get its electricity? The torch goes on and off. And to see how it gets its electricity, if we open it out, you might see one of these. You must have seen different sizes of this in your alarm clocks, toys. The cylindrical electrical cell has two sides, a cap and a disc at the other end. You will also notice a plus and a minus on it. The plus is the positive terminal and the minus is the negative terminal. The cell gets its energy from the chemical which is inside this. When the chemical is all used up, the cell needs to be changed. Let us further study this torch. What is it that lights up in this? When you do this, there is a bulb inside it which glows. This bulb here inside can be taken out and it is so small and will look something like this. It has an outer glass cover and mounted on a brass or a metal cylindrical portion here. Inside it there are two thick wires on which is mounted a very thin wire, and it glows when connected to the cell. The portion which glows is called the filament. The ends of the thicker wire one end comes to the brass portion and the other end goes to the base. So this bulb also has two terminals, one the brass portion and the other at its base. Do all bulbs have that? Well, the bulb that you use at home is much larger and looks something like this. If you notice carefully in this bulb, there is again that thin wire which is the filament, which is mounted on two thick wires here, but they have their terminals at the base because it can accommodate them. Now, if you have a bulb and an electrical cell, do you think this bulb will light up? Well, I think your guess is right because you require connecting wires. Connecting wires such as these you must have seen. Each one of them has a metal part inside and an insulation on top. Every time you need to connect it up, you need to remove the insulation from top and expose the metal part and connect it. One such connection is done here. This is the cell, here's the bulb, and here's a wire which connects one terminal of the cell to one terminal of the bulb, and we connect the other and the bulb glows. But every time you have to light a bulb, you have to hold it in your hands and keep holding it till this connection is there. This is not a very nice way of doing things because it's very clumsy. So one of the good ways is to take a holder such as this and mount your bulb onto it. This enables you to have a fixed bulb, and the holder has two terminals. These are connected to the two terminals of the bulb. Likewise, you can place your battery in this battery holder and connect it in this manner, and you have a firm connection. Now let us see if we can try and light the bulb. Here is a bulb with two terminals and a battery. Let us connect these two. One connection. Connecting one here and another here. In this case, let us connect these two ends. You can have more options. Connect these two. In this case, and also connect this. You can do the same on this one. Connect these two as well as connect this. In this case, now in all these circuits, only two of them are working. The bulb glows only for these two and all others are not working. Let us see why the bulb is glowing in only two of them. If we start with this battery, from the positive, the current would come up till here and there is a gap. This end and this end are not connected. Let us study in this case. Starting from here, this wire is connected to this end. This wire goes here, but there is no connection from this terminal of the bulb to the battery. It doesn't glow. Let us study this one. From here to here, through the bulb and back to this point, and this terminal of the battery is not connected. This bulb also does not glow. In this case, the current flows from the positive to the bulb, one terminal, second terminal, and goes back to the second terminal of this electrical cell. This forms a closed path. Let us see if this path is available here for the current. It goes from here, there is a gap, these two ends are not connected, and therefore the loop is not complete. How come the loop is complete in this case? Let us study that. From here, this white wire is connected to the blue one. Through the bulb, the green wire gets connected to the red and back to this electrical cell. So the circuit is complete in this case as well. So both the terminals of the bulb and the cell are connected, and this closed path for the current to flow from the battery to the device is called an electrical circuit. In this case, there is one cell, one wire and one bulb. We can connect it in this way and the bulb glows. In order to understand how the circuit is complete in this case, let us study. Now there are two terminals of this electrical cell, the negative and the positive terminal. The two terminals of the bulb are 1 and 2. These two are connected and we bring the other two terminals close and the bulb glows. In general, whenever you have to connect a circuit, always remember to start with the cell and the appliance to be connected to it. Use a connecting wire and connect one terminal of the cell, the other end of the wire to be connected to one terminal of the bulb, the other terminal of the bulb to be connected to the second terminal of the cell. Now watch, this completes the whole loop through which the current can flow and your bulb will definitely light up. To understand this better, supposing 5 or 6 of you were to form a circle by joining hands. You would understand that each one of you would need to stick out both your hands and hold somebody else's in order to complete the entire circle. This should also make you understand why any device like this should have at least 2 terminals. Sometimes, despite this entire circuit being complete, your bulb may not glow. Now, what could be the reasons for that? One of them could be that your cell is finished. That means all the chemicals inside it are used up. Another reason could be that your connection is not tight and it is loose, or your bulb could be fused. In any of these 3 circumstances also, your circuit, though looking as though it is complete, may not really work. Now let us see if we can have a choice of running the circuit. For example, in this particular case, I have my circuit complete and the bulb is glowing, and I don't want the bulb to glow now, so I remove it. So make the circuit and break the circuit, make the circuit and break the circuit. This kind of action you must have observed in the torch as well. In the torch you have a switch which allows you to light the torch or switch it off, light the torch or switch it off by using this switch. Now this device is obviously either making the circuit, that is completing the circuit, or breaking it, making a gap in the circuit, not keeping it as a loop. So let us see if we can make a switch for ourselves. You will require maybe a piece of thermocol or ply like I have, one safety pin and 2 thumbtacks. These are the board pins that you use. Take this safety pin and fix it onto the ply. It should be free to move. The other pin you place in such a way that it touches it. This gap should not be very much, not too wide, and should take care that the pin touches it when it is brought close to it here. Now the rest of the circuit can be assembled around it. For example, I have here a circuit here. This is a cell, this is the bulb, the wires are connected, this is one end, this is the other. So, the circuit is not complete. Let us connect one end of this wire to the switch that we have made, the other end to the other thumbtack, and let us see if our switch works. When I connect these two, the bulb lights. This is on, off, on, off, on, off. By choice, I can let the bulb glow or put it off. So, you have just learned a very simple way to make your own switch. Now, the switches in the house are also working on the same principle: make the circuit and break it. But of course, they are a little more complicated in design, but work the same way for your devices in the house. Now, are connecting wires always made of metal? Can we replace them by, say, a thread or a sutli or a plastic cord? That means you would require to know whether the current would pass through any material or not. This particular device can be used to check that as well. That means you will classify materials or elements or things around you which would conduct electricity and the others which would not. So, the ones that would conduct electricity, when placed between these 2 points, would act as a switch which is on, and when something which does not allow the electricity to flow through it is placed here, then your bulb will not glow. This would also become a quick checking device for finding out whether a particular material is a conductor or a bad conductor. If we replace the pin by a cotton cord, do you think this bulb will light up? Let us try that. Remove the pin and place this cotton cord tightly between these 2 points, but the bulb does not glow. This means that electricity cannot pass through this cotton cord. That is, this is an insulator and the pin was a metal and that was a conductor. Let us try some of the other articles that you may find around yourself. Here is a coin, I place it between these 2 points, and because it is a metal again, the bulb is glowing. So, this is made up of a good conductor. This pen I place here, the bulb does not glow, it must be having a bad conductor, which is the plastic cover it has. This spoon also of plastic, let us place between these 2 points and see. Again, despite the circuit being complete, because it is a material which does not allow the current to pass through, the bulb is not glowing. A metal spoon, however, could be different. The bulb glows, good conductor, completing the gap between these 2 points. So, this metal spoon is a good conductor. What about a piece of chalk? Small piece between these 2 points, no lighting of the bulb, bad conductor. Let us see this matchstick made out of wood. Again, though the circuit is complete, bulb is not lighting, so it is again a bad conductor. This peanut peel, do you think it will conduct electricity? Let's try it out with our tester. It doesn't. Also a bad conductor. Eraser, between these 2 points, no bulb glowing, bad conductor. Here's a bangle. Let us try what happens in this case. This must be made up of metal because the bulb is glowing. Take a look again. You think all bangles are made up of metals? Let's try this one. And the bulb doesn't glow. That means out of all these articles, some of them allowed the current to flow through and the bulb was glowing for that. Others did not. The materials that allow current to flow through them are called conductors, and those that do not do so are called insulators. Now, you have seen in your circuit, you require both conductors and insulators, because when you were making up your switch, the board that you used had to be an insulator, because if it was not so, these 2 pins would always be connected by a conductor and the current would continue to flow. This also means that right now in this gap there is air, and air must be an insulator because the circuit is not complete. So our switch worked because the connection between these 2 points, the gap that we had in the circuit, was connected by a conductor, and it doesn't flow when this gap is by an insulator. This will also make you understand why all the wires used in the house have got to be conductors and the covering on them should be insulators. So insulators and conductors can be used simultaneously, and we are going to make a game with conductors and insulators, and let's see how we can do that. Supposing you look at this, and let's see what material we need. You will need a cell, a bulb with a holder, a key with a large enough hole, some connecting wire, a thick metal wire with a plastic coating, 2 clamps, and of course a wooden board. And how this is going to work for us. Now, from this stiff wire, in this section the insulation has been removed, while these have the insulation cover on it. Now, how does this complete the circuit? From the cell, this is the wire that goes through this and back, connecting the key, the bulb, and to the second terminal of the battery. Let us see how such a circuit would work. If you hold the key in your hand and take it up such that it is around, the hole is around the stiff wire, even if the key touches the wire, the circuit is not complete because the bulb is not glowing. The insulation cover on the wire, stiff wire, is not allowing the circuit to be completed. But when you come to this section, however carefully we do that, if the wire touches the key, the bulb will glow. Whether intentionally or otherwise, this bulb is glowing because the circuit is complete. This is how the circuit allows the current to flow from here and through the bulb and back here. This circuit can be used by you to check the patience of your friends. You can have a game to say how steady is your hand. You can do anything with it. You can probably put it up at the fete and check their patience, whether their hands are steady in taking the keyhole right across here without lighting the bulb, because this would mean that the circuit would get complete and the bulb would glow. So insulators, conductors and the circuit elements are all being used in your game to play with your friends, have fun with